Alright, so we saved our scene, all good. I don't know why my laptop's freezing so much. I haven't even had it for that long, don't know. Oh well, if it freezes again, rip. So what we're going to do is drag our script that we made onto our main camera. So this makes it a component of our main camera. And there's a couple of different ways to do it. One is by holding this, dragging it here onto the inspector whilst you've got the camera highlighted. If you let go, it makes it. Let's just remove that. Let's remove this one as well. Or you can drag it onto the thing in the hierarchy itself. See how it's made it here in the inspector? Or if we remove it again, we can click Add Component, start typing in the name of our script. It comes up, hit Enter, it adds it. Let's remove it again, and let's go to Component, the drop down, and we can go down to Scripts and find the one that we made, click it, it adds it in. So there's loads of ways of doing it. We're going to save our scene, go to Console so we can see something happening. Now if we click Play, what should happen is we've got our little variable here that we printed. So if we open Visual Studio, we can see this happening in action. Desktop master race, yeah. But then I can't bring it to work, you see. Whoa, that's really bright. Okay, so it has the value of 1, and we're looking here, and it's printing a value of 1. Cool. Now let's print everything else. Right, my first float, print my first double, and this is a really good way to debug your stuff, really. If you can print stuff, then you know that it's reached that section of the code, and then that saves a lot of head banging. So chart, string, and bool, yeah. Save it, go back here, let it recompile. Let's just clear this. Now if we hit play again, all of them should print. So we've got 1, we've got 99.9, 88.8, we've got 1 again, which could be the string. We have hello world, and we have false. False, all looks good. Okay. So in a nutshell, that's what variables are. You can, add variables together, subtract them, change their values and things like that. My first string could be, if we say, you go like this, that means it did have a value of this. Now we've reassigned it a different value. We can't say, changed without the quotation marks and so on. Yeah. So in a nutshell, that's what that is. Now let's go over logic, loops, if statements, and case statements. Okay, so if statements are used when you want to check some sort of criteria, some sort of value, and say, oh, if this is doing this, execute a piece of code, otherwise execute a different piece of code. So since we've got some values here, my first int is equal to 1, let's just check if it actually is true. So we write if, should be blue, and if we open our brackets here, we can add in our criteria. So let's say if my first int, so that's the integer that we made, is equal to, and to do equal to, you write 2 equal signs, because if you write 1, that means you're trying to assign a value to it, just what we did up the top. So we have to put 2. So if it's equal to 1, close brackets, and then we open it, like the criteria box, with our curly braces, like this, which means execute this block if that above is true. Then we're going to print the value, just what we did a second ago. If it's not the value of 1, so we can write else, then open this block of code. Let's say print, and we're going to hard code in a string and say, oh, wasn't 1. Okay, so what it does is it goes, oh, is this 1? If it is, step into here, do this, and then hop over this, because we don't need to use this bit. If this isn't the value of 1, don't go into here, check anything else, and hop in here and print the thing. Okay, let's go back here. I am predicting that it will print out the value of 1, and it has, because it is the value of 1. Now let's say we change the value beforehand to make it 0. So it starts at 1, then it goes to 0, so it's going line by line, and now we're checking if it's the value of 1. So we clear this, hit play, and it's going to say, oh, it wasn't 1, which is pretty obvious, but that's, you know, the premise behind an if statement. They're very, very powerful, relatively easy to write, and you can use them to pretty much code anything you like. Lots of logic, you know, in games use if statements. It's just the way it is. The opposite, another way of writing an if statement is to write a case statement, and it could be useful if you need to check multiple values. So if you've got an input that the user's typed in, and then you need to check it against, you know, some sort of criteria, then that's what it's useful for. And you denote this, so it's called like a switch case statement. So if you write switch first, and then in the brackets you're passing in the input that you're going to check against something else. So if we say, okay, we're going to look at the value, my first int, and compare it against some known cases. And we do case, then our first case can be, you know, say it's like 0, which means if our variable, my first int, has the value of 0, end it with a semicolon, then execute this part of the code. So let's say do this, and then once that's done, you hit break, and then you have a look at some other criteria. If it's 1, do this, and then we do break. I'll explain the breaks in a second. And if it's not those, but it is something, do this part by default. You know, so it's always going to do something so that your code doesn't break. Okay. Break means go out of any condition that you're in. So we're checking this, and if this is executed, we don't want to then check any of these because we know that it's going to be this one. So we say, oh, just click break, and it means, okay, go all the way to the end of your switch statement and carry on as normal. And that goes the same with all your loops and stuff. If you write break, it's going to break out of it, and you're saving computational time. Yeah, so for case statements, for the case bit itself, you put a normal colon instead of a semicolon, because that's like opening up the case. But then every other normal line of code, you put a semicolon. So yeah, so that can be a bit confusing, but it's repetition really. So since we know the value is 0, let's say we're going to print something. It was 0. And let's do the same thing, let's copy and paste it into here and say it was 1. Save it, and then by default it was nothing. Okay. Right, so let's just save that, go back into here, let it recompile. We're going to clear the console, let's bring this up a little bit, and then we hit play, and what happens is we've got our first print, and then we've got our second one, which is to do with the case statement, and it says it was 0, and that is because we have our value of 0 set into my first int, and it's gone in here and it's printed out. Now what happens if we change this value to something that isn't 0 and it isn't 1? Let's put it as 5. Now if we hit play, it's going to check all that stuff. It's going to print this one because it wasn't the value of 1, but then it's going to go to our default case because it's not 0 or 1. You know, our first two checks, it's just something else. So run this line by default. It was nothing. It also knows nothing. And you can use that for all manner of things. You know, if you've got an enemy that's walking around, and in other cases he's eating food, and then in another case he's just standing still. You could check, have a case statement that checks, you know, is he walking? Is he not? Is he eating? You know, and then you can do things accordingly. You can do the same thing in an if statement, it just looks different. It's like if it's doing this, else if it's doing this, else if it's doing that, and so on. So it really goes down to personal preference, really. But sometimes a switch statement just looks more sense than an if, and vice versa. Right, so I have about 10 minutes before I have to take a break, and then I'll do a stream again after. But what we're going to do now is go over loops. So if we delete all this stuff. Right. Bada bing. Okay, so we're still working with the same method here. A loop means run the same piece of code continuously until a condition is met. And that could be, you know, a counter that goes up or down over time. It could be whilst certain values are true and things like that. And depending on that criteria denotes what loop you're going to use. You could use any loop theoretically, but some just work better than others. So we're going to start with a while loop. And in the name, it means while this is true, or you know, this value is as it says it is, or something. Do this. So if we type in while and then open brackets and say while my first int is greater than or equal to 1, let's say. Then we open our little curly brackets because we need to go in to our loop itself. And all we're going to do is print the value of our integer. And then beneath that, we're going to get this, and we're going to make it equal to itself minus 1. So it starts at, let's say it starts at 5. It's going to start at 5. It's going to say, oh, okay, so when it's greater than or equal to 1, which it is, print its value, then go down by 1, so it goes to 4, and then it's going to go up here, check this, we're still bigger than 1, print the value, turn it into 3, and then 2, and then 1, and then 0. Yeah, I am going to go over absolutely everything. We're going to end on overloading and recursion, so what we did in the lecture, like yesterday or something. So I started with variables, I went over if statements, now I'm going over loops, and then I'm going to go over methods probably, then arrays, then what else is there? 2D arrays, recursion, coroutines, yeah, pretty much things like that. Pretty much everything from the first year. Try catch exceptions as well. Right, let's give this a whirl. So let's save that. Make sure I haven't accidentally put myself in an infinite loop. Doesn't look like it. Okay, let this recompile. And I'll hit play. And what we've got here is gone 5, 4, 3, 2, 1, and then that's it. So it's ran this piece of code 5 times. 1, 2, 3, 4, 5. Starting at the value of 5 and then going down. So that's all good. Let's untick play. And that's the basic premise of a while loop. They're used in lots of programming languages. Since C# derives from C, you know, it just inherits all that stuff. However, C# can use a loop called do while. So if we just bring that down for a bit, and what we're going to do is we're going to write do, and that should turn blue. That means you've written it right so far. And we're going to open some brackets. Now you're saying do this while some condition is true. So, right, so what we're going to do is we're going to use the same condition. So while my first int is greater than or equal to 1, do this. And we're just going to paste in what we've written before, just to keep it nice and, you know, simple. Right. In this case, you need to end this while part with a semicolon because you've got the brackets above. Okay, so you're saying do this, so print the value -1 from your criteria, then check if the value is greater than or equal to 1. If it is, do this part again, check it, do it again, check it, do it again, check it, all the way until you can't do it anymore, then it breaks out. So let's save it, go back to Unity, let it recompile, and we're going to hit play. And it's going to do exactly the same. So you might be wondering, what's the difference between a while loop and a do while loop? Woohoo. So basically they are to do with how they access things. So it's like it's called post, how do I call it? It's like post increment. So it's like it does this after something or it does it before something. So in a do while loop, whoops, it's always going to go into here at least once before checking this criteria. Whereas if you've got an ordinary while loop, it's going to check this before going into here, and if it can't go in, then it's going to break out immediately. So it depends if you want the code to loop at least once versus looping, maybe not looping at all. So maybe your value starts at 0, and then what would happen is, well, let's just do it. Let's say my first int is equal to 0, save it, go back to Unity, let's clear the console, let it recompile, and then we're going to hit play. And then we can see that 0 has been printed, but we're saying, oh, while it's greater than or equal to 1, do this. But because our while loop part is second, it's always going to go in here at least once first. That sort of makes sense. So it's printed 0, and then it's turned this to probably -1, and then it's checking, oh, is this greater than or equal to 1? No, it's not, it's less than, so we need to stop. Okay, that sort of makes sense. I'll go over 4 loops, and then I'm going to have to wrap up for part 1, because I have to eat food and everything, but then I'll come back, and then I'll just go through the rest of it really. So that's good if you've got, if you're making a game and you need some sort of action to happen continuously. Maybe you're walking or something and that needs to happen forever. You can say, oh, while the space bar is pressed down or the right key is pressed down or something, then do this. But let's say you want to have a timer, or you want some sort of increment to happen. You want something to go up or down or something. For that you need a for loop, and they're very specially made to handle this sort of thing. So if I'll write out the syntax and explain it as I go along. So if it's a for loop, you write for, and it turns blue, which means you've got it right so far. And then you open the brackets, and in here it's going to put your criteria. And there are 3 main segments to a for loop. So the first is your starting position, what value you're going to start at. And then the middle part is your termination condition. So say you start at the value of 0, you want to say, oh, okay, loop until it equals 5 or something like that. And then the final part is your increment or your decrement. So are you going to increase by 1 with each iteration? Are you going to decrease by 1? Are you going to increase by 10 or something like that? So to show you what I mean, we're going to make an integer within this thing, in this loop, and let's call it index. And we're going to give it a value of 0 to begin with, and then we stop that with a semicolon. So that's part 1, our starting position. Now we're going to say, okay, do this for loop whilst index is less than 5. That's our termination condition, that's part 2. And then part 3, the best of the prequels, is our increment condition. So let's say we're going to increment by 1, and in a for loop that has its own special key operator for this. So if we type in index and put ++, this means get index and then add 1 to it. Okay, so that's the first line of a for loop. Just as we did with a do while and a while, we need, and with if statements as well, and with case statements, we need to actually open the loop so that we can put the code inside. So all we're going to do is add some curly braces here. So we've opened it and we've closed it, and in here is what's going to loop until this for loop has been satisfied. So let's say we're going to print out the value of index just for the time being. So what it's going to do, it's going to say, okay, start at 0, go into here, print the value, so it should be 0, and because 0 is less than 5, it's going to add 1 to index, so now index is equal to 1. Go into here, print it, so it should be 1. Because 1 is less than 5, it's going to go back up to the for loop, increment it again, so it's now 2, go in, print its contents, which should be the value of 2, and then because that's less than 5, it's going to increment again, and so on, until we get to 4, because it can't go to 5, because we're checking if it's less than. If we wanted it to go to 5, we just do less than or equals to, you know. So, depending on what you want to do. So let's save that, and let's go into Unity once again, let it recompile, and then we're going to just clear the console, and we're going to hit play. Now what should happen is, yeah, exactly what we've got here. So we've got 0, 1, 2, 3, 4. And that's because we've ran this part of the code continuously 4 times. Because 4 is the last value until we get to 5, because an integer is a whole number, so we can't have any decimals. And that's all it's doing. Let's say we tried to start this at 5 and check if it's less than 5. Do you think it would print out once, or do you think it would print out none? Let's just give it a try. So we're going to clear this, let it recompile, and we're going to press play, and what's going to happen is nothing, because you've started your start position in something that the termination condition can't actually fulfill. So that's probably something to be wary of. Similarly, instead of plus plus, you could put minus minus. That means go down by 1 each time. And let's say, while index is greater than 0, so we can start it at 5, let's go down by 1 instead. So let that recompile. And then we're going to hit play. And now we've got 5, 4, 3, 2, 1. So for loops can be used for all sorts of increments and stuff like that. Right. So that's a good overview of variables, if statements, case statements, then loops. We've got while, do while, and for. There is one called for each, but I'll go over that when I cover arrays. But for the time being, I'm going to stop there. Eat some food or whatever, and then I'll come back and do part 2, and then I'll go a bit more in depth with Unity as well, and hopefully we don't have so many crashes. But yeah, so I hope that was useful, and have a go at practicing like yourself, get up to speed with programming, so that by the time you come to your professional practice week and stuff, it'll be a piece of cake essentially. And you can see that it's all C# programming. So just because it's in Unity doesn't mean it's any different. This interface just looks different to Windows Forms. Chances are when you go into a job, you may never use Windows Forms again. You may never touch Unity ever again. But the premise here is to build on your transferable skills. How can you apply this code to any given scenario? No matter what software you're using. You may enter some sort of film firm that uses Unity to develop animation films, so it's not making a game, it's doing something else. The possibilities are endless. So yeah, that's part 1, and I'll be back probably 2 hours, I guess. Yeah, probably. Alright, cool. See you there. Yeah, probably about 2 hours, I think. But I'll let you know anyway on all the sort of channels and things. So yeah, until next time, ciao.